So for today's video, I am going to talk about vector addition. Basically, this video will show you how to perform or how to add vectors applying the different methods. Okay, it was introduced to you from the previous lessons that physics is a science of measurement, and that when we measure, we use numbers to represent these measurements. These numbers are what we refer to as physical quantities. Physical quantities are of two different types, the scalar quantity and the vector quantity. When you say scalar quantity, these are the quantities that involve magnitude and its corresponding unit. While when you say a vector quantity, this is a quantity that involves magnitude, the corresponding unit, and direction. Let's say, for example, a car is moving 60 kilometers per hour. 60 kilometers per hour is used to represent the movement of an object, which is the car. Okay, so 60 kilometers per hour. When you look at this quantity, it involves 60, which is the magnitude, and km per hour, which is the corresponding unit. So this quantity is an example of a scalar quantity. Yes. So next, let's say a car is moving 60 kilometers per hour directed north. 60 km per hour directed north. You look at the quantity, it involves, again, the magnitude, corresponding unit, and the direction. That is how simple it is to differentiate a scalar quantity from a vector quantity. You only have to take note of the presence or the absence of direction. When the direction is present, that quantity is of course an example or itself a vector quantity. Recall the term arithmetic, which has been introduced in the big idea and thin focus of this chapter. It implies that physical quantities, both scalar and vector quantity, can be mathematically operated. We can add, subtract, divide, and multiply them. But while scalar quantities can be regularly added, subtracted, multiplied, or divided, vector quantities are treated differently. Why are they treated differently? It is because they involve direction. This direction always affects the result of these operations or mathematical operations. Okay, so in vector addition, the sum of two or more vectors is called the resultant vector, or simply resultant. It is usually represented by the bold and italicized capital letter R. Bold and italicized capital letter R. Yeah. Or the regular letter R with an arrow on top. As what you can observe, your book usually uses this representation, the bold and italicized capital letter. In our discussion and in your output, we are going to use this symbol. So we wouldn't find a hard time italicizing and bolding the letter. I guess the book also used this representation because it's quite hard as well to put an arrow on top of the letter while encoding because that is encoded. So para-paraan mo na siya, class. Take note that vector addition has two important properties: the commutative property and the associative property. When you say commutative property, that is an addition property in which variables that are added together can be interchanged. Let's say, for example, you have vector A and vector B. So, in commutative property, that can be A plus B can also be written or will have the same result when you interchange the variables and have it as B or vector B plus vector A. Well, when you say associative, that involves already a group of variables. That is, for example, you have vector A plus vector B Okay, so in associative, you are going to group first the variables. That is A plus B. After adding A plus B, the result is added to vector C. Or you can have vector A plus vector B plus vector C, in which the group here is vector B and vector C. After adding vector B and vector C, the result is added to vector A. In associative property, the changes in grouping, the variables to be added, cannot affect or still cannot affect the resultant vector. At this point, let me introduce to you the different methods of vector addition. We have generally two methods: the graphical method and the analytical method. The graphical method is subdivided into two methods: the parallelogram and polygon methods. So these methods are under graphical method. While the analytical method is also subdivided into two. These are the methods. First is using the laws of sines and cosines and the component method. Okay, so these two are under analytical method. Okay, so first we are going to, or the first method we are going to discuss is the parallelogram method. Here are the steps in doing this method. So first is using a suitable scale. Draw the arrows representing the vectors from a common point. Okay, example.